Touchboards, the largest supplier of interactive whiteboards, offers a variety of blowout specials on used and refurbished interactive whiteboards that you will not find anywhere else. Log on to touchboard.com to learn more.
Hello everyone, we're going to get started. My name is George Rivera and welcome to our webinar. I'm here with Jack Brand, who's the president of HT Instruments, and we're going to be discussing solar measurements. And before we get started, I just want to tell you a little bit about T Equipment and give you a range of products that we carry and the type of markets that we cover. As you can see on the slide here, pretty wide range of categories, a lot of portable instrumentation, fixed instruments as well. And if you need anything, we're happy to work with you from our sales team. And one of the things that we pride ourselves in is the website on the front end that you could see. Has a smart navigation on the filtering on the left. It has a smart search and other great features that you would normally expect in a modern retail website, but now from business to business side. And on the back end, on our accounting and order processing, and being able to give you updates. You can see in the bottom part of the presentation there some additional capabilities that we have to be able to help our customers get them the information they need. And with that, I'll turn it over to Jack. Thank you for coming.
Thanks, George. Great to be here. Thank you, everybody, for taking time out of your afternoon to attend this. And thanks to T Equipment for putting this on. First, the objective I have today is really just to share information about the measurements with which you're doing in the field in order to, make these PV systems work well, fix them when they're not there, etc. And touch a little bit as to why are there specialized tools available rather than your traditional, voltmeter, ammeters, etc. I got this slide. And I looked for one that was about a revolution. Because I think if you're in solar today, you are in the middle of a revolution. Everybody watching this, I'm sure, is feeling the energy out there. I've been now to a few of the solar shows. This year, I think, is in Vegas again. And the energy you get there really feels like people believe they are changing the world as we're going through it. So, I guess in general, it's just welcome to the revolution. It's going to be a whole lot of fun. Next slide.
Okay.
So there's just some headlines. If you take yourself out, what's going on from 20,000 feet. These installations in America are growing at about 30% per year, which should be lots of opportunities for everybody. It really breaks down pretty easily, as I'm sure you see out there. Commercial, big projects, big money, a lot of testing needs, a lot of maintenance overall. The residential, I am just shocked how I can see, a house with nothing on it on Monday and Tuesday their solar system all working. So the ability to lay that is happening. Here in the Northeast, and I think it's happening moreover, you're seeing a number of, I would argue, hybrid models. George showed me this. I hope you can see it. It's in a magazine called Electrical Wholesaler, but it really talks about why is there kind of a new surge or continuing surge in photovoltaics. And it comes down to two issues, right? There's tax benefits that the investment tax credit was approved for the next, I think, 5 years, which offsets the capital cost. But equally as important as the efficiencies that they're really bringing into this world are substantial. The amount of dollars per watt continues to go down almost at a quarterly basis. So this has really helped. And in fact, what I was with a customer, I guess just Monday or Tuesday, and he was sharing that a lot of his customers actually are Wall Street types who, I don't think they're in it for the environment. They're in it to make money, and so they're very much engaged in testing, making sure this thing is up and running efficiently, as the whole day. The last part is really the farms, and there it's really interesting. Like in the Southwest, you're seeing very, very big farms being created. A friend of mine was managing a few Well, power plants, and a couple of them were coal, and they failed the pollution test of the California laws, so they had to shut them down because it was too expensive. And with all the analysis, solar came up as the best option to supplement that power that they lost with the coal. So, and they looked at everything, gas, everything else. So the solar thing, I think, is really, for one, it's real, and it's driving this revolution. Now we're into why you came here. Really, you know, what are driving more measurements in photovoltaic? And I can tell you about 3 or 4 years ago, there was a big increase in folks making these measurements. It seemed to wane actually a little bit, but it's definitely coming back. And the big drivers in my mind are from this operation and maintenance, right? So the slide I'll point it out, but it's basically when you put a new system in place, there's kind of an acceptance testing to make sure things are running, they're safe, you know, nobody's going to get hurt if they go around it, and you know, everything's kind of running the way whoever paid for it expected. Also, we see this increasing, you know, some periodic change. I haven't seen anybody do it more than every year, but you know, often these big fields will have some measurements going on every string at some frequency, which is driving demand for kind of this O&M service business that seems to be growing quite large. Troubleshooting, of course, I'm sure if you're in the O&M thing, you're going to get a whole mess of people. If something isn't working, you're going to be asked to get out there and solve it quickly. The other driver seems to be, when I'm talking to folks, is differentiation. So how does an installer, how does an O&M company differentiate themselves? Well, having really great testing methodologies backed up by reports, charts, whatever they want in their portfolio seems to be a way that many people are trying to differentiate themselves from everybody else. So finally, measurements. There's really 3 kind of measurements that are going on. There's this insulation, connectivity, and basic safety stuff that really is done when you start. The second part is, you know, there's this whole IV curves, and we'll get into this. And this is really about ensuring that the panel is meeting the specs. So in essence, the customer's getting what they bought. And there's also an efficiency thing which you can kind of measure from the sun all the way to the grid, how the power's flowing. I'm not going to get too much into this today, but it's part of the game of PV measurements. So do the next one. Mm-hmm. So this is actually, so this might be a product thing, but this is on the back front page of our solar catalog. But I think it depicts the world of solar pretty well. So you'll see here on the left, you know, that's a number of strings going together. You'll notice at the upper right there's a little device there. That's actually how we read the irradiance coming from the sun at that moment in time. And you know, we take many measurements around these solar fields, the strings, and in fact maybe down to the panel level if it's needed. As you know, they all go up to that combiner box, right? All the power from as much as you can fit into that box, thrown to an inverter, right? Goes to AC, whether it's, you know, single phase or three phase out. But this is the world, and what we try and do is show how do we attach to it. So the middle is this thing called commissioning test, and we'll get more detail, but that's kind of the first step where many people will start after they put a project in or want to go out and do some safety testing. So you do next slide. Mm-hmm. So are these measurements different? I think this is a great question. You know, so, and it kind of supports why you see vendors like ourselves making specialized tools. So the first category is, well, you know, there's a bunch of measurements that are really the same, and that's true, right? A DC power measurement hasn't changed because we're driving it from a photovoltaic cell. The AC power out of your inverter, well, that hasn't really changed either. And continuity is pretty basic, right? So those things are very similar, although there's some nuance about the DC power if you want to do it with some, you know, for some of the measurements about the panels. What's different? So the huge difference is really around the measurements we take about a panel or a string. And largely this can be framed up as these IV curves, which is of course current voltage. The two measurements that many people want to do, and you'll see the specs in the sheet, is short circuit current and open circuit voltage. So again, open circuit voltage is something everybody understands, right? You just have it open circuit and measure the voltage between the positive and the negative, and you will measure open circuit voltage. Short circuit current, a little more problematic because you got to actually short the thing, and these things can put out 8 amps. So I don't like to play with that kind of energy, and so that makes a little difference. It's really nice to have a machine that will take that, do the short circuit, and measure the resulting current. And an IV curve, if you are not familiar with one, and this really comes out of the whole electronics world, what semiconductors are tested to, because in essence, a panel is a bunch of individual semiconductors put together to generate the electricity for us. So an IV curve, if you take a standard, XY graph, on one axis you'll have short circuit current. That is defined by no voltage. Then on the other one, you'll have open circuit voltage. So it's current going to voltage. And our products, and they all run similar, we make 128 measurements along and be able to draw that curve, thus creating this IV curve. From there, you can then determine, hey, is this meeting the specs or not, and gives you a nice picture of whether or not it is and where it isn't. And it also has an ability, if something's really broken, it shows up just like a sore thumb. I mean, there's something wrong if the curves aren't nice and pretty. The mixed one, which is kind of interesting to be honest with you, is, so everybody is used to making insulation measurements talking about a mega, and I see I misspelled it. But what's the challenge in doing it within a string of panels? Well, unless it's the middle of the night, that thing's generating potential and voltage across that. So when you want to measure insulation, you are, actually let's go to the next one. Okay, I'm going to hold off on that. I want to get to this. I'm sorry about that. Should practice more. Before we get to the mega, which is an important topic, this is about the terms. So I guess you're not really a new industry if you don't have new terms. So there's a whole lot of 3-letter acronyms out there that will determine, and pretty much people need to understand it working in the field. So the first thing is called standard test conditions. STC is the short for it. And this is what all the characteristics or specifications of the panels are created to. So it's 1,000 watts per meter is the amount of irradiance coming down when they test. It's at 25 degrees C and has an atmospheric density of 1.5. And to be honest with you, I don't even know what that means. But that's the criteria everybody uses to say this is the environment that's present when I agree to the specs of my device or my panel. So this is key whether or not it's making those specs or not. The operating conditions are what you measure in the field, right? So this is the real measurement, no kidding around. When it says you have a VOC of 800 volts, that's the real measurement. So the mission to decide, are you getting what the vendor promised or what the manufacturer promised, is to somehow translate what you measured in reality with up to the standard test condition to determine, hey, okay, so it's making the spec, I feel great about that. Or it's not, and I'm really concerned. So that's what these tests are trying to do. What that means is we must understand how much irradiance is hitting, how much sun is hitting us at that time, making the real measurement, because the chances of it being 1,000 watts per meter, 25 degrees, is about 0. So that's the role these machines play. So keep that. There may be some questions about it. no problem. So now finally get back to the installation testing. There's actually standards, and
Next slide.
yeah, next slide, I'm sorry. One back. There's actually standards out there, and to be honest with you, a lot of times when I talk to American customers and people working in the field, they care far less about standards than the Europeans do, which most of these things were created, maybe 10 years ago. But they're pretty good ideas, to be honest with you. So there is a installation testing outline and a recommendation for a standard. And it really just asks for testing the short circuit current, the open circuit voltage, the insulation of all your active cables, right? Make sure nobody gets stung if they hit the wrong bar. And then the continuity ground, making sure this thing is grounded where it's supposed to be grounded. Recently a good customer of ours was bringing up a new guy. He was testing it and he was getting, I think it was in the zone of a couple of kiloohms on the continuity test to see if they were grounded. And his first response was, hey, what's wrong with the measurement? I said, well, could be a measurement. It also could mean you're not really grounded. And in fact, he wasn't. So there was some things that went on. But so these are kind of nice safety standards to kind of go to. Interestingly enough, the standard and many people, they just want to know if it has short circuit current, open circuit voltage. There's no standard, if you will, for that. But most of the customers we have actually use these reference cell where they measure the irradiance so that combined with your real world measurements and how much irradiance is going on at the time, you can determine is that panel, field, string meeting the manufacturer's spec. So that's the key, is whether or not it's making the spec. So you put it in, you're getting ready to let it roll, it will generate electricity perhaps. Is it making the specs? So that's how that's how we do it. So back to the original thing. Why doesn't a Mega work? To as well as we would expect for doing insulation measurements or standard insulation tester is a better way. So this is an active device we're playing with. This is a solar string that is putting out voltage. That voltage acts like a huge noise source because it can generate power if it were connected to a load, but it's definitely going to generate voltage, it's going to be skipping around. And so that's kind of an unintended signal coming at it from the device it's trying to test. So no matter what happens, the answer is going to be off because of that noise present. So this is one of the core reasons actually that these specialized tools came up. And there's really two ways these specialized tools do it. And we're not the only ones that make it. There's another company that also sells through TEquipment, but the methodology is very much the same. You short out the positive and negative of your string, much like in the eye short circuit measurement. Because then they're the same node, then you can make an accurate measurement of the insulation without having all that noise hitting you if you just had a standard insulation tester. So that's one method. There's another method that I think we have patented, but it enables you to do insulation through the whole field in one button push. And what we do there is we actually measure the voltage between the terminals, if you will, and use math and get rid of it. And when we get rid of that, then we are able to really measure, an entire combining box. I did it the other day for this customer. Out of that combiner box, we made one measurement, and we could determine what was the net insulation out of that converter. That box. If it had been a problem, then we know it's somewhere in there, and we could have gone down to the string level to figure it out. But that's one of the key reasons why these specialized tools can add so much value, is they make these measurements really easy to do, rather than just using a bunch of GP tools. So that's so much about the installation stuff. The last part of here is just to look at, what are these IV curves? I hope you can see this. It's The IV curve should look a lot like this thing on the bottom right. You'll see there's a few key points. There's a place with which the I short circuit is. On the bottom right, there's a place where open circuit voltage is. You'll see the key point there is what's sometimes called MPP, or the maximum power point. That's where you want these things running, because that's where you're getting the most power out. And an IV curve tracer gives you this picture of what's happening in your string or in your panel itself. The other thing, when you measure it, when we combine the measurement you're taking with the irradiance that's present at the time, and we understand the dynamics, the specs, if you will, of the panels you're using, we can take your measured IV curve and pop it, I guess, up or down to the standard test conditions. Therefore, we can say, hey, it is making the specs, it is doing exactly what the manufacturer told us. If it's not, then we can actually use that as a way to tell the manufacturer this panel's not working. But that's a real advantage. It makes it very, very easy to see almost the total characterization of a panel or a string. The reason you can't do this in the field is because there's so much current that these instruments do take the current in. And you can have 100, 200 amps, and no instrument that we have or anybody else has can really accept that kind of current coming through it. So typically this is a measurement that's done on a panel, or more likely a string. But it's a very interesting measurement, and it's really what people use to characterize or even troubleshoot if they're not getting what they want. That's about all I planned. I didn't want this to be an hour long, go grab coffee, but that's all I want. I hope it was pretty clear about some of the differences in the measurements. Why are people measuring? What are they hoping to accomplish? And probably more importantly, why have these specialized tools been created, and how can they bring value to me? So I'm going to end it there. I'm hoping there's some questions out there for, well, that's nice. If anything was unclear.
I got one question, Jack. Can you explain again why you can't just use a clamp meter and a DMM to measure the current?
I went over that a little fast. So the truth is you can. You can do a lot of good work with the traditional tools that we use. You can definitely measure how much power you're getting out of a string, even a field, because those are not crazy. The key point is there's certain things you probably don't want to do. So as an example, shorting out a string is putting 8 amps or thereabouts on the new panels through your short. And in an environment, in an instrument like ours or others, you actually don't do it very long, and it's contained, and you're being very careful about it so that nobody's at risk for having that kind of current come. So you can get a lot of your, in fact, the customers I was with earlier this week, they had been doing a lot of their work this way. They didn't have as robust testing methodologies, I guess, but they clearly were getting a lot of their needs met. When they saw, though, they really thought there was an advantage to not only making it easier to do, quicker, but the documentation was good, because they were doing, writing the results on a clipboard or something. And I think, I don't know, they're telling me they're doing a couple of 100 megawatts these days, and that's a lot. It's a lot of writing on newspapers. So a lot of the measurements can be done with traditional tools. There are just some that are difficult, like the insulation and the PV. Well, you can even do PV if you want to, but it's a nightmare, because you need a variable resistor and a bunch of other controls. But you can get a lot done with normal test equipment.
Okay, there's another question. Can you go over the need for the reference cell and how it relates to the STC?
Yeah. So there's many ways to do this. The fundamental is you're trying to figure out how much irradiance is coming at that point in time. Because we take the irradiance and use it with the calculations from the specs as to what is that equivalent standard test conditions. Is it meeting it or not? We've actually chosen to use, it's actually a photovoltaic cell in there to measure it. We think that's the best answer because these photovoltaic cells or panels, whatever you want to think about it, respond to different frequencies of light. So if you're taking the light measurement from the entire spectrum, it may give you a too high, if you will, impression of how much energy is out there. Because again, the specs of these panels only adhere to certain frequencies in the spectrum. So we think we eliminate some of that potential error by using a semiconductor itself or a photovoltaic cell to make the measurement as to how much energy is out there in the sun. And we think it's more accurate that way. But the irradiance number is critical to get from what you really measure in the field to what it would be if it was at the standard test conditions, which is what you bought. You bought, or your customers bought, the performance from the data sheet. So that's how we do it. I think that's a little clearer.
Okay, yeah. So one more. So how frequently do people check their installations?
Yeah, so that's like I've never met anyone doing it more than once a year. And some are infinity, so that's the span. But the big guys the big farms, or even people who are putting them on the top of buildings, maybe an acre of them or whatever on these large commercial warehouse. I think they pretty much want to make sure every year they're going to be testing something like, at minimum, the installation test. There's some folks that are even so aggressive on making sure they know what's happening that I've seen they will do the IV curves that we talked about earlier when they install. And every 12 months, get a new one and make sure each string hasn't degraded over that time frame. That's probably the most aggressive I've seen. So it's anywhere in between. Personally, these things live outside. There's a lot of rabbits and varmints around, and there's part of me that thinks, especially things like insulation and grounding, that's not a bad thing to check every year, just to make sure, not from a safety, just from a safety point of view, because, good people like us are out there always trying to do it. We want to keep ourselves safe.
Any other questions from the group? I don't see any coming in. We'll end it there. Appreciate your joining us, and we'll get we have your emails. We're going to send you an email with the slide deck, and if you have any questions afterwards that you think of, just please reply back to us and or give us a call. At T Equipment, we have several sales engineers, and we also have access to the folks at HT Instruments as well. Again, thank you so much for joining us today, and I hope we got some useful information. Again, Jack, thank you.
Thanks, George. Thanks, everybody, for your time today. Have a great afternoon.
Thank you.